Hello everybody and welcome to another one of James's videos. Today we're going to be doing trigonometry grade 11 equations. This is now the type 2 question. If you have been following the series, we have had an um, intro video, 2 equations, and we've also had a type 1, which is tan, and now we're going to be dealing with type 2, which is also kind of a tan method, but I want to explain to you why we're using this technique and when do we see to use it. So what we're going to look at is we've been given solve for theta if theta is an element of minus 180 to 180, and it's saying that root 3 cos theta is equal to sine theta. Now what already coming into my mind is like, oh, whoa, we've got 2 different trig functions here, which is very new to me in terms of equations. So what approach do I take? So the first thing you look at is if you have sine and cos on either side of the equals, right? And their angles are the same, we're going to be using something called the tan method. Oops. Okay. So when do I know to use the tan method? When I have sine and cos on either side of the equal sign and their angles are the same. That is very important. Okay. So that is when we use tan method, and I'm going to show you now what I mean by tan method. So because we have cos and sine on either side and the angles are the same, we can divide both sides by cos, guys. So if I divide both sides by cos theta, those coses will cancel. But then what do I have? I've got root 3. Therefore, I've got root 3 is equal to sine theta over cos theta. Now, surely this looks something like the identity that we are familiar with. What is the identity? Don't we know that tan of theta equals sine theta over cos theta? Identity. Yes, so that means we can change it. So therefore, root 3 is equal to tan theta. Now it's in a form of an equation that we can get a reference angle from. Hey, so we can go reference angle straight away here and say, cool, shift tan of root 3, and that's going to give me 60 degrees. And then again, we're going to say, cool, we know that tan is positive. This is a positive. Where's tan positive? First and third. But remember, in the previous video, we mentioned that because tan repeats itself every 180 degrees, we only need to do the first quadrant in this case. Okay. So then we're going to say, cool, first quadrant, so theta quadrant. So therefore, theta equals 60 degree plus k180. K is an element of integers. That is my general solution for this question. But what did they give us in the beginning? Excuse me. They gave us a domain, right? So that means we need to sub in values for k until it falls out of my domain. So let's sub in. So if we say if k equals 0, therefore theta equals 60 degrees. Yes, that falls within my domain. If k equals 1, definitely out, right? Because then it would be 60 plus 180, which is 240. Let's see if minus 1 works. So that is going to work, and that is going to be minus 1. So we're going to go 60. So it's going to be minus 120, which works. And then if I make it minus 2, it's going to be too big, right? And those are my solutions to this question. Theta is equal to 60 degrees and minus 120 degrees. Easy peasy lemon squeezy. Okay, so that is an example of a tan method type question where when we have sine and cos on either side of the equal sign and their angles are the same, we can always make a tan by dividing the sine by the cos because the angles are the same. Great. The next one will be an example where the angles are not the same. So please stay tuned. And if you enjoyed this video, please click the like and the subscribe button. And also all these notes are available on the James book, which is for sale. So if you are keen to get one, please drop us a message and we'll get in comms with you. Great. Have a good one.